Hello everyone, good evening. Thank you for attending the session. In the next 20 minutes, I am going to talk about how we developed an LLM-based solution to augment the investment decision making by a PA firm. Okay, what is the business problem that we are trying to solve? If you look at it, every PE firm, they need to make a right investment decision to improve their business. It starts with identifying a target company and then performing a due diligence and then creating an investment memo which can be used by the investment committee to take a decision about the investment. Our goal is to improve the quality of the decisions made by the investment committee. We developed an LLM-based solution to create the draft version of an investment memo, and also we created the LLM-powered chatbot to provide responses to the analyst queries. In this talk, I'm going to focus upon how we improved the retrieval performance of the Q&A chatbot. Central to the investment decision making is the investment memo. It can be used to identify the growth opportunity, and also it can be used to identify the co-investors for an investment. What does it contain? It contains the business model of a target company. It also contains the financial metrics. It contains the competitive landscape, and also it contains the risk assessment. All of this information is presented in a text, table, and figures format in the investment memo. Our goal in defining a solution approach is that how can we extract this information from text, tables, and figures and represent in a way that can be used by LLMs to generate the response. Table extraction. If you see this particular document, it contains header, footer, free-form text, and table text. We are using document intelligence to extract the text from this document. The problem is that we are also getting the noise. When we looked at it, we identified free-form text contains the text from the tables. We detected the text from the tables and we removed it. That's how we are able to improve the quality of the free-form text. Coming to tables, we fine-tune the document intelligence model so that we can extract the tables from the document. Subsequently, after extracting the table, we convert the raw tables into the markdown format and we send it to LLM to generate the summary of the table. What we did here is that we generated the summary at the row level, column level, and the whole table level. That way we got a rich understanding about the tables that are present in the documents. Coming to images. Images which are in the table format, we followed the similar approach that I described in the previous slide. In terms of figures, we identified the bounding box and we extracted the figures and we sent those figures to the large vision model to get a description of the images. Once we extracted all the data, the next step is that how do you represent this data in an efficient way so that you can perform retrieval. For text, we converted into embeddings and we stored the text in an embedding database. If you look at a document, many times the information in a document does not follow the sequential order. Say for example, you have a chunk in a page which will reference to the text in another page. We identified all those scenarios and we kept that information as a metadata tag in our vector store. Similarly, for table summaries also, we are storing the reference table information as a metadata tag in our vector store. For images as well, we extracted the images and kept in an object store and we placed the image location as part of a metadata tag in our vector store. Most of the investment demo documents that we worked upon, they are in the presentation format. Information is more relevant at a page level. We did the chunking at a page level. For the larger chunks, we broken down the chunks into multiple smaller chunks using semantic chunking technique. Here what we did is that we looked at the sequential sentences, we identified the sentences that are dissimilar so that we can break them into the separate chunks. Once we extracted the chunks, the next step is to create the embeddings out of the chunks. Here, we fine-tune the embeddings model. In this case, we used a combination of the embeddings model from OpenAI, and also we used an open source model, BGG, to fine-tune on our data set. It helped us to get the better performance for our embedding models. We extracted the embeddings for our chunks and we stored them in our vector store. What we did here is that we also provide the role-based access to the users so that they can access relevant chunks which they have access to. After performing the chunking and storing the embeddings in the vector store, the next step is that we created the indexes on top of the vector store. Vector stores, the way that they work is that they perform the approximate search when you ask for a query. How do you measure the performance of your vector search? What we did here is that we did the full search using KNN algorithm. We got the initial results and we did this comparison against the approximate search results that you got it. This way we understand the performance of our retrieval, and then subsequently we optimize the parameters of our indexing algorithm. In this particular case, we are using HNSW algorithm. We optimize a couple of parameters to improve the retrieval rate. So using metadata tags helped us to improve the quality of our retrieval. In this particular case, we extracted the metadata tags for every document. We are storing industry, company name, document name, and also references to the tables, text, and images as part of our tags in the vector data store. How do we ensure that we are always providing the responses on the up-to-date information? This is where we implemented the streaming and the batch ingestion depending upon the rate of change of the data. We also capture in the KPI in terms of time to vectorize, and this metrics helped us to understand how frequently the source of data is changing and which is available in the vector store. After completing the indexing, the next step is that how do you respond to the user queries? So what we did here is that how can we understand the user queries better? In this particular scenario, we augmented the user queries with the abbreviations and acronyms used by the analysts. Subsequently, we are decomposing the user query into the sub-queries. Here, what we did is that we are sending the reference query template as a guidance for LLM to decompose in the main query. We have generated the query plan. Along with that, we are also able to identify the dependencies for the subqueries. This information we are providing to the user for confirmation. Upon his confirmation, we are generating the response. Here, we are providing access to the user so that he can ask questions on the document for which he is authorized to access. Once the user asks a question, we are identifying the metadata tags. We are using the entity extraction models to extract the entities from the user query, and then we are using those entities to perform the filtering on our vector store. The relevant chunks are retrieved for generating the response. So our goal of initial phase of the retrieval process to improve the recall rate. What we did for that, we reduced the threshold of the similarity measure so that we are getting all the relevant chunks for generating the response. As a next step, for a chunk, wherever there is a reference to a table, we have used table QA model. We are using the Tapas model from Google, which we fine-tune to generate the responses for the queries that were asked from a table. The good part is that this particular model is providing the aggregation operations on top of your table. It also gives you the reference cells that were used to perform the aggregation operation. In terms of references to the images, we are sending those images to the LLM model to generate the responses. These chunks were included as part of our retrieval process. Along with focusing on the high recall rate, we are also considering how diverse our retrieved chunks are. In this particular case, we are including the results from the freeform text, table, and images as part of our retrieval process. For that, we have used the marginal relevance score to retrieve the chunks from tables, text and also from the figures. Once we have identified all the relevant chunks from the vector store, the next step is that we are sending all these chunks to the cross encoder, which helped us to give us the better relevance score for all the retrieved chunks. We use this relevance score to optimize the precision of our retrieval process. Okay, let's take an example. What happens if you come across a scenario where we have conflicting information that is retrieved as part of the retrieval process? Here, we have two versions of the document. If you look at a scenario, in the second scenario, we have the retrieved chunks from both from the older version and the new version of the document. Here, we are applying post-processing filtering to take the latest chunk and generate the response to the user. The interesting part is that in scenario 3, we are only able to identify the relevant chunk from first document, old version of the document. In this particular case, what we are doing is that we are notifying the user that there is a new version of the document that is available so that he can refer to in case if it is required. One other important thing that we are doing is that how can we enable our users to trust our system? That's where we are providing the confidence score. How are we calculating the confidence score? It's based upon combination of the similarity and the re-ranking score that we are generating in the previous steps. What we are doing here is that for low threshold confidence score, we are letting the user know about it. Along with that, we are also providing the reference queries from our database where the confidence score is very high. It helps the user to ask relevant questions and get the responses from the LLM. So one other thing we are doing is that how do we improve the quality of the content? This is where only authorized users are allowed to provide approval for allowing the documents to enter into the vector store. Once they approve, we are creating the embeddings and storing in a vector database. One more thing which we are doing is that we are collecting the feedback from the user, and this feedback is reviewed by the authorized reviewer based upon which we are improving the quality of our retrieval process. One additional thing which we are doing here is that in case if the user is not providing the explicit feedback, we are trying to calculate the implicit feedback. How are we doing that? We are looking at the sequence of questions that were asked by the users, and we see that how similar the subsequent question is. If the similarity score is higher, it gives an indication that the user is not satisfied with the response from the previous question. One more thing that we are doing is that we are doing a thorough analysis of the questions that were asked by the users. We converted all the queries into the embeddings, and then we are projecting those embeddings into the 2D and 3D space, where we are doing the clustering and then identifying the patterns in the questions that were unanswered by the vector store. This technique helped us to improve the overall performance of our retrieval technique. How are we measuring the overall retrieval quality? These are all the different elements that were involved in generating the overall retrieval process. So the retrieval score is multiplicative effect of the performance of each of these individual elements. What we did here is that we looked into each of these individual elements and identify which of them are performing lower, which is a bottleneck in our retrieval process. We applied all these different techniques to improve the quality of our retrieval process. In terms of data extraction, we improved the data quality both for preform text, images, and tables. Similarly, when you are representing the data, we provide the cross-references and we fine-tune the embedding model. And in terms of understanding the query, we are creating the decomposition of the query based upon the reference query template. We are augmenting with the abbreviations, and also we are using the metadata tags for filtering the information. One other thing that we did is that we optimized the parameters of the indexing algorithm to improve the retrieval score. And finally, we are sending all the retrieved chunks to the cross encoder so that we are improving the precision. One more important thing that we did in the beginning of the project is that we spent good amount of time to understand the users of our system. It helped us to identify what kind of question that they are going to ask on the system. One more thing which we did is that we understood how they are performing the manual search to retrieve the documents. This process helped us to identify the pre-filtering and post-filtering conditions of our retrieval pipeline. By involving the users, we are also able to generate the golden truth data set for validation. How are we improving the user experience? We applied different techniques. We are providing the autocomplete feature as part of the question entering, and also we provide the toggle feature for asking questions on the internal document. We use the lower temperature. For asking questions on the external data, there they have the flexibility to change the temperature so that they create creative responses. One more thing that we did is that we provide the session context so that we have the ability to understand the user queries better. And the last thing that we did is that we provide citations. It helped the user to understand the reference sources that were used to generate the response. These are the results that we have. We created a data set of 200 queries and we used them to evaluate the performance of our system. We categorized into 4 different categories, and this is how our system performing in each of these categories. If you see, the overall performance of the system is 87% in terms of the overall accuracy. We are now focusing on how can we improve the responses to the queries that were asked on the multiple companies. Sorry. This particular slide talks about how did we improve the overall performance of the system. If you look at it, the biggest jump in performance is observed when we are able to extract the information in a proper way and represent it in a way that we can use it for efficient retrieval. The second best performance that we observed when we implemented the query understanding technique and also applied the filtering on our retrieval process. In the other scenarios, we just observed the marginal improvement in the performance. Yeah. This is how we are able to achieve the overall performance of the system. In the coming 1 month, we are planning to deliver the next version of the system, which includes the information from multiple sources as well.